The effective rate of interest is the equivalent annual simple interest rate that would yield the same amount as compounding n times per year or continuously after 1 year. Effective rate of interest is a way of comparing different interest rates. So you can look at this as a comparison tool. In order to calculate effective rate of interest, you're basically calculating, you're investing $1 for 1 year. So if you look at these formulas, you invest $1 for 1 year. So if you look at this formula, remember our compound interest formula, A equals P times 1 plus R over N to the NT. If I put a 1 in for P and a 1 in for T, I would be left with this quantity here, 1 plus R over N to the N. So basically I want to calculate, if I invest $1 for a year, how much am I going to make? So here's the amount I'd have at the end of a year if I invest that dollar, and I subtract off that initial dollar. So it's basically calculating how much would you make if you invest $1 for 1 year at a given interest rate. So I'd rather you guys avoid having to memorize this, because all this is this formula, our compound interest formula, with a P of 1 and a T of 1. We're investing $1 for 1 year. And again, it's just like a nice, easy comparison tool. And for continuously compounded interest, remember our formula for continuously compounded interest, P times e to the RT. Well, here, if you put a P of 1 and a T of 1, you'll just be left with e to the R. So if you want to see how much you make on that $1 at the end of a year, you just subtract off that initial dollar and you'll get the amount that you make. So it's a nice, easy way to compare different interest rates and different compounding periods. So let's go right to this example 4. Suppose you want to buy a 5-year certificate of deposit, CD. You visit 3 banks to determine their CD rates. Liberty Bank offers you a 2.25% annual interest compounded monthly. Smith Mutual offers you 2.30% compounded quarterly. And UNC Bank offers 2.15% compounded daily. We want to determine which bank is offering the best deal. So if we compare the rates themselves, the first one's the lowest annual rate, 2.25, or actually the third one's the lowest annual rate, 2.15. The largest would be 2.30, the middle would be 2.25, but we have to consider the compounding periods. Although this is the lowest rate, it's compounded most frequently. This is compounded daily. And although this is the largest rate, the highest rate, the 2.30, again, it's compounded quarterly. It's compounded less often than the UNC Bank, which is compounded daily. So in order to compare these, again, we're going to pretend that we're investing $1 for 1 year at each of these rates, and we want to see how much we would earn, how much interest we'd earn. So we want to find the effective rate of interest, so we're going to compare the effective rates of interest. So some problems in your homework will explicitly say, calculate the effective rate of interest. But in this problem, it's just suggested that you compare these so you guys can find the best deal. Okay, so we'll first look at Liberty. Okay, so for Liberty, our effective rate of interest, 1 plus, now here we've got our R of 2.25%, so 0.0225. Our N is 12 because it's compounded monthly. So even if you want to label that on here, here's your N is 12. Here's your R is 0.025. Oh, sorry, 0.225. So close those parentheses, raise to the N to the 12th power. So this would be the value of that $1 at the end of that year. So then if we subtract off the original investment of $1, it'll show us the money that we would make, the interest we'd make. So we can enter into the calculator. We want 1 plus, oh, whoops, I forgot my parentheses. Parentheses, 1 plus 0.0225 over 12. Close those parentheses. Raise that to the 12th power. And now you could either enter this now and then subtract off 1, or you could enter it as all one entry. So this basically tells us if we invest $1 for 1 year at this interest rate, we would make 2.27 cents or 0.0227, etc. dollars. So the interest that we would earn, so we'll approximate this as 0.0227, and we know that that is 2.27%. So if we convert this annual interest rate, 2.25 compounded monthly, into its effective rate of interest, that's equivalent to 2.27% if we invested that $1 for 1 year. Now let's compare it to the Smith Mutual. So the Smith, let's find its effective rate of interest. So with the Smith, we've got our rate here, 0.0230, compounded quarterly, so our N is 4. So we'll fill in 1 plus 0.0230 over 4 to the 4th power minus 1. You can enter that into your calculator and you're going to get approximately 0.0232. So that is 2.32%. So the effective interest rate for the Smith Bank is 2.32%. So we can see this one is higher. So even though the compounding periods is fewer, it's only 4 compounding periods for Smith, because that initial rate, that 2.30, that annual rate is higher, this actually ends up being a better deal. But we have one more to compare. So let's compare the UNC. So let's find that effective rate of interest. So for UNC, we've got 2.15%. So our rate is going to be 0.0215. Compounded daily means we have an N of 365. So here we go, 1 plus 0.0215 over 365 to the 365th power minus 1. So here we've significantly increased the number of compounding periods, but that interest rate, initial interest rate, was lower. But this effective rate of interest lets us compare these. So if we enter this into the calculator, we're going to get approximately 0.0217. So the effective rate of interest for the UNC CD would be 2.17%. So again, although the compounding periods is highest with UNC, the compounded daily, because that interest rate was lower, the 2.15, it's actually not the best deal. So these are your effective rates of interest. So the best deal, we can see, would be the Smith. So this is your best deal. So this effective rate of interest is a convenient way to compare different interest rates and compounding periods.